Ladies and gentlemen, good morning. My name is W Lyons from GGI Golden Grain Group. Very good to have the opportunity to be able to speak to you. I'm going to introduce to you about the China flour mill industry. It's an update because I have given a similar presentation about China some years back, and I thought it'd be a good opportunity to update you and let you know what's happening, because as millers, we try to learn from each other. Millers have different ways of doing things in different countries. So some of the things I'm going to talk about, perhaps they can give you some new ideas for you to try in your mill, in your country going forward. First of all, just to give you an overview of the China wheat production, it's 135 million tons a year. When I started making this presentation, I guess, well over 10 years ago, 15 years ago, we spoke about China wheat production, 105, 110. But step by step, as farming becomes more efficiency, fertilizers, yields have increased. The production in China has gradually increased year by year. This last year, we've seen a lot of imported wheat coming in, particularly from the US, but also Australia, France, some other countries. Population based on the 2020 census, 1.402 billion. That's billion. Big country, China, a lot of people live there. We now say that there are 3,000 flour mill groups which have official government certification. So these are companies that are officially registered. So in order for them to do business, they need to have an official certification. In the past, I talked about maybe there was 10,000 flour mills in China, but there's been a lot of consolidation in recent years. There's been a lot of changes, which I'll introduce as we go forward. For the purposes of explaining the structure of flour mills, we can divide them up into super large, large, and medium-sized flour mills. These are basically, they're the mainstream, if you like, and they account for 77% of the total installed capacity. I'll come back to this in a moment. Li is not only the largest flour mill in China, but it's also the largest flour mill in the world. The current daily capacity, one-day capacity, is 63,000 tons. Now, Li has probably at least a dozen different sites throughout the wheat growing region. Each site is between 3,000 and 5,000 tons. Each mill is between 600 and 1,000 tons. In recent years, they tend to build 1,000-ton single lines as the most efficient type of mill for the China market. And again, I emphasize, these types of capacities are applicable for China. Probably not, there's no other country where this is practical. From 1995, basically flour milling groups in China have become privatized. So the government has very, very little participation in flour milling. They still own some mills, maybe for strategic food safety reasons, but by and large, flour mills are privatized. In the last 30 years, we've seen probably more than 50 new mills being built. And of course, this has resulted in a severe overcapacity. Net profits margins are very low because of the intense competition. Now, I mentioned to you that the total wheat production is 135 million tons a year. Of that milling wheat, there's 87 to 90 million tons used for flour production purposes. So that's to say there's around about 30 million tons that's used for animal feed. So we just look at what we mean by these different groups. So the super large, basically there's 4 groups. Those would be the Li, Kofco, Wilmar, Jiangshahe. And these have a daily capacity of between 20 and 63,000 tons a day. And they represent almost 50% of the total installed capacity. The large scale mills, then those are the mills that have a capacity between 4,000 and 9,000 tons. They are 8 groups, and they represent around 14% of the installed capacity. And then the medium-sized mills, these are the mills that are 1,000 to 3,800. They are 35 groups, and they have 16% of the capacity. So most of these, all of these groups, they have flour mills in different locations in different regions. They don't have all their capacity in any one location. They spread the capacity out. So as I said, this group, the super large, the large, and the medium, yeah, they represent 77% of the total installed capacity. So they're 47 flour mill groups, if you like, which has a market share of 60%. Based on 80% utilization. So total output is based on 300 days per year because there's holiday time, Sundays, and so on. And then the remaining flour mills, these are the small and medium-sized mills. These are the ones that have a capacity of between 200 and 900 tons. So yeah, there's 2,500, 3,000 companies. So market share of these companies, it's still considerably large. 38 to 40%, so that's around 30 million tons. So it's a sizable chunk of market share that these small mills still have. Up to now, they've been able to survive because they have strong brands. They focus on quality, niche marketing. They have after-sales service. They sell to the baking shops, cake shops, and so on and so forth. So to some extent, they can command a premium for their flour. So yeah, they've been able to survive up to now. Going forward over the next 3 years, well, we already see that there are under construction or confirmed, there are at least 17 new projects over 1,000 tons a day. Some of these projects are 5,000 tons. Some of these projects are 3,000 tons, different companies, different projects. So this is an additional capacity of 22 million tons a year. I mean, these are incredible figures. I mean, it's hard to understand. It's going to add up to an increase of 25% of capacity over the next 3 years. And this doesn't take consideration of those mills that are below 1,000 tons. So probably there's going to be at least 20, 30 of those mills less than 1,000 tons that will be built each year. So I think it's fair to say going forward, yeah, the market share of the small and medium-sized mills is going to gradually erode from this, you know, this 38, 40%. It's going to erode. And so that's to say the 3 large groups, yeah, their market share, which is currently 60%, yeah, we can expect it to increase towards 70, maybe even 80%. So going forward, it's going to be very hard for these smaller mills to survive. Now, just to recap on the end product, what is the flour used for? Well, 35% of the flour is used for steam breads. Now, steam breads, there's many, many different types of steam breads, many different sizes, and many, many different presentations, if you like. But these particular steam breads are the solid ones. And then, of course, there's stuffed steam breads. These are the ones with custard powder, bean paste, shrimp, vegetable, pork, meat, all sorts of different fillings. So this is 35% of the total flour is used for all sorts of different types of steam breads. Noodle, also another 35% of flour is used for noodle, all sorts of different types of noodle, big business in China, dry noodle, wet noodle, and so on. So between noodle and steam bread, that represents 70% of the flour output is used for those 2 categories. And then the remaining is Western bread, pizza, cookie, cake, and so on. Now, in recent years, been a continual enhancement, if you like, of the wheat cleaning process, because as you can see, these steam breads and some of these dry noodles, they have a requirement for bright low ash flour, speck free. And so, you know, the Chinese wheat quality, it has a lot of screenings in it, a lot of stones in it, seeds, barley, oats and barley, a lot of impurities. And the only way to make clean, low ash, speck free flour is to clean the wheat better. This is a wheat cleaning diagram. Now, you know, we have the raw wheat, we have the first tempering and second tempering. In the past, when we were building mills 20 years ago, for example, in Indonesia, in Philippines, in Thailand, Malaysia, Vietnam, the wheat cleaning process was very simple. We generally had raw wheat, we had the first cleaning, and then we had the tempering, and then we had the B1 roller mill. We didn't need the second cleaning because, you know, going back 20 years ago, a lot of the wheat, most of the wheat that mills were using was what I call first tier, first country wheat. I mean, wheat from US, Canada, particularly Australia, very clean wheat. So at that time, you know, mills weren't buying Indian wheat or Black Sea wheat, or they weren't buying wheat from non-traditional origins. But of course, you know, as you know, in Indonesia, for example, there's a lot of Black Sea wheat that's coming in, Argentine wheat that's coming in. And so this type of flow diagram is also very applicable if we're building a new mill in Indonesia. This is kind of the new standard, if you like, because the mill needs to be able to clean that type of wheat better than before. One first cleaning is just not enough. So you will notice here there's some differences, let's say, to the traditional wheat cleaning flow. Apart from the second wheat cleaning, is much more detailed. So basically, we have the scale, we have the separator with closed circuit aspirator, we have the destoner. So that's pretty standard. But then what you notice is we don't use the disc cylinder or cylinder separator anymore. The machine basically is not good enough to remove black seeds and impurities from some of these non-traditional origins. Non-traditional origin, I mean a Black Sea or in India or in Argentina. So we do this process a little bit different. Millers, if you're listening, you will understand that this type of destoner, it's a 2-deck destoner. We have a top deck and a bottom deck. So there's a 70-30 split. So the top deck is the light wheat with the small seeds and the oats and the barley. And that material traditionally was sent to a cylinder separator. Now we send that material to what we call a classifier, which takes out the small broken, small grained material, and we send that to screenings. And then the whole wheat with the oats and the barley, it goes back into the mainstream. And then we come to a scour. Now, this is a new type of scour. It's a very aggressive type of scour. It has the effect of aggressively polishing the wheat. And the effect of doing that is it creates a lot of fine bran, if you like, that looks a bit like this. It probably represents maybe 0.1%, maybe even a little bit less. But it allows the wheat to be cleaned, to be polished. And that achieves a lower ash than before. So you could say, yeah, a very aggressive polishing scour machine. Now, I'll take you back into the flow sheet again. And after this scour, we then go to the another wheat separator with closed circuit aspirator. The closed circuit aspirator can remove that light outside bran material that you've just seen a moment ago. We then add the water for first temper, and then we lift up again and we add the water for the second temper. We now use automatic tempering machines on both first and second to give a better accuracy, better moisture control of the moisture going into B1. If we have accurate moisture on the B1, then the milling is much more consistent. If we have a B1 where the moisture is changing, then that means the flour quality is going to change. So we are controlling the moisture at the B1 to a more accurate degree compared to before. And so then after the tempering, we then go to the second cleaning, which is much more detailed than traditionally. You can see there's destoners, because a lot of this non-traditional wheat has a lot of stones, so we have to run it through a stoner again. And then we have a two-stage scarring process. We have a gentle scarring, and then we have a more aggressive scarring, same as what we had here in the first section. And then once again, we have another separator with aspirator. And then the last machine that we use in the wheat flow is the color sorter, and that removes the black seeds, the oats, the barley. Anything that is a different color to wheat, this machine will remove. And there's also, yeah, there's a retreat section, so we can clean the wheat to a very good degree of efficiency. So that's to say, yeah, cleaner wheat can be presented to the B1, which can make cleaner flour, can also reduce bacteria content and the filth content, and so on. So in general, yeah, the wheat cleaning process, more attention has been placed on to make it more precise, if you like. Color sorter, again, yeah, these machines now pretty much have become standard. The cost of these machines has been dramatically reduced in recent years. And for those of you that are not familiar with the color sorter, well, you can see these dark grains, seeds, beans. This machine is able to remove even discoloration in the wheat grain. So that's some sort of a diseased wheat kernel. The machine is able to remove it, so it can perform a much better job than the traditional disc cylinder separator or cylinder separator. In recent years, anytime I've made this presentation, I've emphasized that in China, yeah, the roller mill length has greatly increased. I mean, traditionally, you know, the roller mill length was maybe 12, 13 millimeters. And now the roller mill length, it's greater than 16 millimeters. Even 16, 17 tends to be the new standard. So moving towards the Japanese milling system, if you like, plant sifter surface also much increased plant sifter surface. So we can segregate the semolinas more precisely and control the granulation of the flour, which I'll come back to in a moment. Purifiers, more purifiers, so we can purify the semolina. We can remove those bran specks before we grind the semolina down into flour. You can see, now this is just an example, okay? It's not a typical standard, but you can see this is one flour milling group. They wanted to produce a higher extraction of the premium low ash flour. And this is the diagram that we came up for them. So there's obviously a lot of machines for 350 tons. I mean, this would kind of be a 600-ton mill. Maybe in an Indonesian world, if you like, or a Philippine world. But you can see 350 tons one day. There's 6 8-section purifiers. We have 15 purifiers. We have 26 roller mills. So this is a pretty extreme example, if you like. But you know, the flour mill company, they wanted to build this type of mill because they wanted to increase their extraction of their premium flour. So maybe before they were making maybe flour 1, maybe 20–30% extraction at less than 0.4. And now with this diagram, they're able to increase that towards 60–65 at 0.4 ash. So, you know, different customers have different solutions. So this is just an example. Now I come back to the flour granulation because there's been a lot of study that's been done about this in China in the last number of years with universities and so on and so forth. And this is why I said that I emphasized a moment ago that in China, the trend is to do more gentle grinding on the reductions as opposed to very, very heavy grinding with a lot of heat. Because when you do very, very heavy grinding, it also produces a lot of fine flour. And based on baking studies that we have done, that has been done also by the universities, fine flour, so anything less than 50 microns, it does not produce a good baking result. So what we want to do is we want to optimize the grinding process so that most of the flour that we produce falls between the range of 50 to 150 micron, because that appears to be the optimum particle size to give us the best baking result, whether we're making noodle or steam bread or even Western bread. So anything that's too fine or anything that's too coarse, then the baking result is inferior. Again, the damaged starch content, this has to be calculated. The standard has to be made based on the wheat that you're grinding. For sure, it's not that high means good. It needs to be controlled. Too high damaged starch can also produce an inferior end product baking result. So between particle size and damaged starch, these are two areas that a lot of Chinese flour mills have done a lot of study in recent years with universities. And that's why we have a greatly enhanced flow diagram in order that we can control and segregate the flour granulations. So if we look back, yeah, basically the flour machine quality has greatly improved in recent years. I mean, there's been an incredible demand, domestic demand. Over 50 new mills have been built, so that's created a lot of research and development. It's also a lot of competition, so that's pushed the standard within the workshops and the paint finish and so on and so forth. Probably over the last 30 years, yeah, China has been the largest machine flour market in the world because they have built so many mills. And because of that, a lot of the Chinese machine manufacturers, they haven't really needed to go to the international market because they've been very busy within the domestic market. Our group, we tend to focus on the big mills within the China market. So anything that's over 1,000 tons, we're certainly involved with because when it comes to flow sheet technology, flow sheet design, we obviously have a lot of experience because of all the international projects that we've also done. So we have a lot of knowledge, if we like, to contribute to the development of flour milling technology in China. The other unique thing about flour milling in China is that no one flour mill group tends to buy from one supplier. It tends to be that maybe for roller mills, they buy from one company and plant sifters from another company. And the idea of that is just to optimize the flour mill design. This is the China formula. Like that type of system is clearly not going to work for the international market because you just don't have the after sales service. But I'm just explaining to you, this is the system in China. Finally, there's just some few pictures of the latest mill that we have done in Indonesia. This is a 600-ton mill. Most customers, whether for big mills anyways, whether they're in Indonesia or Central America or Philippines, They tend to want to pay more and buy the stainless steel. They want to impress their customers. Of course, they have HACCP, ISO, and so on. So the expectation for hygiene is much greater than before. Machines need to be able to be cleaned. Access needs to be improved, and so on and so forth. So there's a lot of reasons to pay a little more money, if you like, for the stainless steel roller mill, which is like I said, what most customers are buying now. Plant sifters, purifiers, scales, flour collection conveyors, spouting. And yeah, again, also in China, you know, most of these big flour mills, yeah, they have to use robots. The prices have come down quite tremendously. We use Japanese robots, so sometimes we use ABB. It depends on the customer, it depends on the local service. But you know, really, for a large flour mill, not only is the availability of labor may be difficult, but also the management of labor is very, very time consuming. So in order to reduce the labor that's involved in handling flour bags, then definitely robots is the way to go. I think this is a 5,000-ton warehouse, and you'll see very, very few operators. Check weighers, metal detectors, they're kind of standardized for most new flour mills that we do now. Okay, so that's it. Thank you very much for your time. I do hope this time next year that we can have an in-person event and we can meet each other face to face. It was encouraging to see the IAOM in Dubai a few weeks ago having an in-person exhibition where many people attended, many suppliers attended. So let us hope and pray, if you like, that we can do the same. So in the meantime, be safe. Thank you again. Thank you for listening. Bye-bye.